Hi everyone, hope you are enjoying my videos, and in this video I am going to explain the most important thing from the multi-threading synchronization concept. This is very important from interview perspective as well as in your future projects. While you work on the multi-threading, it is very important to understand. Every Java programmer should have a good knowledge on this synchronization concept. Today we will take a small example and I will explain how synchronization works. Okay, by the end of this video you will have the understanding of the synchronization keyword. Okay, let us start with a simple example. Okay, I created a class called number generator. Okay, I declared a variable, private variable counter. So what I'm going to do is I create two threads. Okay, and each thread will increment 10,000 times this counter. Okay, and I will start these two threads simultaneously. So at the end of the output should be 20,000, right? So let us start step by step what I have done. I created an instance of number generator. So I'm calling the generate numbers. Okay, so I have a method called generate numbers in this class. I created an instance of this and called the generate numbers. In this method what I am doing, I am creating two threads. Can you see? This is one thread and this is another thread. Okay, what, let us see what each thread is doing. Okay, if you if you don't know anonymous inner class, it may be little confusing, but there is nothing difficult. Generally one way of creating thread is passing the runnable instance to the thread constructor, right? So instead of creating a runnable separately, what I have done is I am used anonymous inner class. Okay, what is the syntax of this meaning means create a, it is not saying to create the instance of runnable, it is saying that create an instance of the class of the anonymous class which implements the runnable interface. See, this creates an anonymous inner class. Okay, so you are asking to create an instance of the anonymous class which implements this runnable interface. Okay, now in this run method, you know, right, you have to override the run method and perform the task. So in this run method what I am doing, I am incrementing the counter 10,000 times, and in the same way I am creating another thread. Okay, what I am doing here, same, I am incrementing the counter 10,000 times. So I am calling t1 dot start, t2 dot start. Okay, what is the output you will expect? You will expect the counter becomes 20,000, but let us run this and see what happens. Can you see? Counter value is just 352. Shall we run again? 774, 911. Why? Because when you start the threads simultaneously, what is happening is actually this main thread, the code in the main thread, see, whatever the code is in the run method, except that everything is in run method right now in this example, right? So this line also executes by main thread. This logic will be executed by t2, means thread 2, and this logic only gets executed by t1. So when you start the threads simultaneously, these three threads run simultaneously, and what is happening is before thread 1 completes the thread 1 and thread 2 completes the work, the thread main thread getting chance and it is ending, means the last line of the main thread is executing and it is dying and it is completing its work even before waiting for thread 1 and thread 2. Only if thread 1 and thread 2 completes, then the counter values will be 20,000, right? So you have to tell join means you are requesting the current thread. What is the current thread here? Main thread. So you are asking the main thread to wait. When you say t1 dot join, you are asking the current thread. In this scenario, where is this line? This is executed by main thread. So you are asking main thread to wait until the job of t1 is completed, and again you have to wait for t2 also, right? Only if t1 t2 completes, then the value will be appropriate. Okay, let us see. So it will throw an exception. I am catching them. So now see. Okay, let us see if this fixes the problem. Can you see? Can you see? 20,000 output is the correct output, but it is not coming properly. Sometimes it is 12,000, sometimes it is 13, sometimes it is 16. So what is happening? So when you start these two threads simultaneously, what can happen is it looks like the counter plus plus is like a single operation, but in reality internally what happens is counter plus plus is not a single step. First thread has to read the current value of the counter, then increment, and then assign the incremented value to counter. So what can happen is, so assume, so now what is happening? You have started two threads simultaneously. So assume present current value of counter is 100. Then what can happen? See, threads means you can't guarantee that when this thread loses control and when other thread can get control. So what can happen? Assume, so counter plus plus is not, even though it looks simple step, internally it will be three steps like this. First it has to get the current value of the counter. Assume it is counter is 100, but even before incrementing and assignment, another thread can get chance. That is called threading. In threading, you never know when your thread loses the control. So after executing part of the counter plus plus, see, all these three steps makes this statement internally. So once the thread gets the value, assume counter value is 100 currently, so the thread one gets the value of counter and it may lose control and another thread may get chance. So assume t1 gets 100, but before executing these two lines, thread 2 may get chance now. So counter, it count a thread 2 reads the first, reads the counter value, so still it is 100, right? So t2 gets 100. Now assume the thread 2 got some sufficient time to perform these steps also. So what will happen? It increments by 1. So thread 2 making counter to 100, 101, because it got sufficient time to assume like that. It got sufficient time to execute all the steps. Now what will happen after? So this is completed. Okay, assume now, sequence 1. Assume this is sequence 1. Assume this is sequence 2. Assume this is sequence. Now the thread 1 again got control. So got control. Now what happens? Already it read the first value and kept earlier, right? So what was the value earlier? 100. So now it won't execute the first line, it will execute next two lines. Now it will make, actually the value should be 101 plus, currently the counter is 101, right? So the thread 2 should make it 102, but what is happening is, since the first line is already executed, it has old value, so it will make the counter as 100 plus 1 is equal to 101. Actually the value is already incremented by the thread 2 to 101, so the thread 1 should make it 102, not 101. But since the thread 1 loses control after executing first line, and thread 2 incremented, thread 1 is not having any idea that this 101, the counter became 101. So since the thread 1 read the value when it was 100, so it will try to increment by 1 with old value, so it will make 100. So can you see, actually by the end of this time it should become 102, but it becomes only 101. So that is the problem. You cannot guess the correct output. Sometimes it is 12,000, sometimes it is 10,000, sometimes it is 11,000. Sometimes you may get correct output. If you execute multiple times, there is a chance to get 20,000. Can you see? Sometimes you may get correct value, but not always. So what you have to do is, you have to use the synchronized keyword. Okay, synchronization means every object will have a lock. Okay, internally every object will have a lock. Assume like a bathroom. So when you enter the bathroom, what you generally do? You will close the door so that no one can enter, right? In the same way, every object will have a implicit lock. So number generator will have one lock. Every object, if you create an instance of number generator, it will have one lock. Okay, so when you create a number generator, it will have a implicit lock, like a lock to the bathroom. Okay, so what you have to do is, you have to get that lock. Okay, so assume bathroom is like a lock object. Assume bathroom is an object. So what happens when one person enters? He locks the bathroom so that no other person can enter, right? In the same way, when in the object also, whenever, so you compare the person entering the bathroom as a washroom as a thread. So thread also should get the lock on the object. Okay, every object will have an implicit lock, right? So when a thread starts performing a task, it has to get lock on the object. So what happens is, then no other thread can get the lock until the first thread completes its task. So what I will do is, instead of incrementing like this counter plus plus plus, I will create a method void increment counter, and I will say counter plus plus. You have to declare the method as synchronized, and instead of this line, call the increment counter method. Call increment. Now what will happen is, assume in the same situation earlier. Okay, T1 read the value of the counter See, earlier earlier you are saying counter plus plus. Now what you are doing? You are calling the increment counter method. The increment counter method is declared as synchronized. That means what will happen is when one thread enters the increment counter method, then I said right, the object will have a implicit lock. Every object will have a implicit lock, right? Number generator. Okay, number generator will have a lock. Assume this is a lock. So when one thread enters, see, when assume the value of counter is 100, so it thread 1 is trying to increment to 101, so it calls increment counter. Since this method is declared with synchronized, so when thread 1 enters, so when thread 1 calls the increment counter, when one thread enters the synchronized method, okay, what will happen is this lock will be closed. Okay, so when one thread enters the synchronized method in the object, see, number generator is a object, it will have a lock, right? So when one thread enters a synchronized method, when one thread enters synchronized method, the object will be locked. That means no other thread can enter any synchronized method. Okay, see, to enter the synchronized method, thread should have a lock, but thread 1 when thread 1 entered the synchronized method increment counter, this object is locked, so this lock is obtained by thread 1. So that means like a person entered the washroom, he closed the door. So when can another person enter the washroom again? This person who entered the washroom has to come out, then only this lock will be released, right? In the same way, until this thread 1 comes out of this increment counter, this lock won't be released. So when the thread 1 tries to increment to 101, even though these steps contains 3 steps, until these 3 steps are completed, the lock won't be released, because currently thread 1 entered the synchronized method, so object is locked. So if assume another thread got chance, but it won't enter the synchronized method, because assume the thread 1 executed part of the step and it loses the control. Assume it read the 100 and it loses the control. Suppose thread 2 got chance, but earlier it can increment the counter because it got chance, but now what it is doing, it is trying to call the synchronized method. But you know, to call the synchronized method, the thread has to get the lock on the object, but the lock is already obtained by thread 1. So even if thread 1 loses control and thread 2 got chance, it cannot call the increment counter, because to enter a synchronized method, every thread should have a lock. But since thread 1 already acquired the lock of the object number generator, so until thread 1 comes out of the method, the thread 2 cannot enter. So again sometime after some time thread 1 will get chance again, so it will increment perform these 2 steps also. So the T1 will make it 101. Then what happens, once the synchronized method completes, the lock will be gone, means the lock will be released. So now what happened, the thread 2 can enter now thread 2 can enter. So thread 1 completed, right? So there is no guarantee that thread 2 will get control after T1. Even T1 may get control again also, but assume thread 2 get the chance now. Now thread 2 got the lock and lock on of the number generators, means thread 2 entered the synchronization method. So thread 2 got the lock on the object. So thread 1 cannot enter now because thread 2 acquired the lock. When one thread enters the synchronized method, it gets the lock on the object. So no other thread can enter not only this synchronized method, any synchronized method. Remember this line. To enter the synchronized method, thread has to acquire the lock. But if any thread already entered any synchronized method, the thread is already the lock is already obtained by some thread, so no other thread can enter any synchronized method. So now there is no problem. The increment, even if the thread 1 loses the control after the first step, until these two steps are completed by thread 1, even if some thread get the control, it cannot enter the increment counter. So the thread 1, after making 101 only, other thread will get chance. Now see, run, we will run again and again. Can you see? Now we are getting the correct output. Earlier what is happening? You may get 20,000 sometimes, but not always. But in real time, you should get the same output always. So that is the purpose of synchronizer. That means, I am repeating, every object will have an implicit lock. So when one thread enters the synchronized method, see, in a class there may be multiple synchronized methods, right? So remember, when one thread enters the synchronized method, that thread will take that lock. So no other thread can enter any synchronized method, because to enter the synchronized method, that thread has to acquire the lock. But already if some thread enters the synchronized method, that lock will be taken. So you are understanding, right? So to remember these 2 points, to enter a synchronized method, you need to have a lock. So if some thread already taken, when the lock will be taken by the thread, when one thread enters the synchronized method, that the thread will take the lock on the object. So no other thread can enter the synchronized method until that thread which acquired the lock, means how the thread acquired the lock, by entering the synchronized method. So when will that be released? When that thread comes out of that synchronized method. Okay, so after synchronizing, so one thread, after reading the value 100, there is no chance that before executing these two lines also, no other thread can enter and make the change the counter variable. Only after incrementing value by 1, another thread can get chance. Even the case with the same thread 2 also, after thread 2 makes the value 1 or 2, and assume thread 2 got the value as 1 or 2, and maybe thread 2 loses control after first step. So thread 1 gets the chance, but it cannot execute, because already after calling the increment, thread 2 enters acquires the lock. So until thread 2 makes completes these two steps and makes the value to 1 or 3, the thread 1 cannot enter. Okay, hope you understand the synchronized concept. Thank you.